Okay, so I'm going to do page 475, number 7. I have it done correctly now, but it took me several attempts to get it done and get it correct. So as I'm processing teaching this, I think the verbiage and getting students to have multiple practice problems with understanding conditional probability and the vocabulary and the way that we say things and the way that we write them mathematically could be the challenge. So this problem starts off with a 2%. We're testing for opium use. So we're going to have positive tests and not positive tests. And so we're also going to have opium use and no opium use. So there's a 2%. There's a 2% false positive rate and a 5% false negative rate. So translating that into words first, so 2% false positive and 5% false negative. So translating that first of all into the idea of conditional probability, a false positive means that it's the probability that somebody tests positive given that there's no opium usage. And that probability was 0.02. The false negative is the probability that they are not positive or negative. They are negative, which means they're not positive, given that there is opium use. And that's how I look to write this idea of negative versus positive, is that it was positive versus not positive. In my head, that's how I was setting that up. Then from there, I also am going to really quickly find the probability of not positive given no opium, which is going to be 1 minus 0.02 or 0.98. And then we're also going to have the probability of positive given opium, and that's going to be 0.95, which is the complement of not positive and opium, given that there's opium usage. And then there was one other probability that we have. The probability of opium usage is 0.01. The probability of no opium usage is 0.99. So the first challenge for me was to get the idea of what a false positive and a false negative were written in this idea of conditional probability. The next part of it that was challenging to me, that took me the several times, was the probability that they're asking to find. So reading the book says, find the probability that someone who tests negative for opium use does not use opium. So a lot of students, and me included, the first time I read it, I was looking for the probability of not positive given that they do not use opium. But the reality of it is, in part A, I'm actually looking for the probability of no opium usage given that they did not test positive. So I read that again. It says, find the probability that someone who tests negative for opium use does not use opium. So we're actually finding the probability that someone does not use opium knowing that they tested negative. So that was the first challenge that I found. So once I got over the challenge, conditional probability and Bayes' theorem, this idea of conditional probability, it's the probability of the intersection over the condition. And so that's the way I teach basic conditional probability with my students, is that it's the intersection over the condition. So because these are related to each other, they're not independent events, we don't look at the intersection as an intersection, we look at it as a conditional probability times the probability of the condition. So we are going to go with the probability of not positive, given that there's no opium usage, times the probability of no opium usage, the new condition. And then I'm going to divide this by the probability that they don't test positive. Well, they don't test positive in two ways. They don't test positive here, and they don't test positive here. So we need to get just the not positive. So that's going to be probability of not positive given no opium times the probability of no opium plus the probability of not positive given that they actually do use opium times the probability of opium. And then I add those two together, I get the probability of just not positive. And the above one, I get not positive and no opium. So now I'm just going to go ahead and substitute the values that I actually found. So not positive, no opium is 0.98. And then no opium is 0.99 divided by the positive, not positive, no opium, which is 0.98 times 0.99, and then plus not positive and opium, which is 0.05, and opium 0.01, which gave me a probability of 0.999. So the probability that someone who tests negative, who does not use opium, has a 99.9% chance of actually working out. That's good for these opium tests that they're using. Because obviously, when we're doing these kinds of tests in the real world, we don't want false positives and we don't want false negatives. We could liken this and have a conversation of what this might look like now with COVID testing, especially with the amount of COVID testing that we're actually doing. All right, part B. And again, the verbiage is what got me, because it says find the probability that someone who tests positive for opium use actually uses opium. So I'm actually looking for the probability that somebody actually does use opium, given that they actually test positive. So I'm going to base that on my positive tests. So I'm going to find the probability of positive given opium use times the probability of opium use. There's my intersection over the condition, and the condition is that they actually test positive. So we can test positive twice. We can test positive with opium and we can test positive with no opium. I'm gonna run out of space. No opium. Which gives me positive in opium is 0.95. That makes sense. 95% of the time, if somebody is on opium, they test positive. That's good. Times the probability of opium, which is 0.01. Divided that by positive in opium, 0.95. Times 0.01 plus positive no opium 0.02 times no opium 0.99, which I got a probability of 0.324. So there's a 32.4% chance that someone who tests positive for opium actually uses opium. Again, maybe not the greatest level of probability. Thank you.